Hello, everyone. Welcome back to another deep dive.
Hello.
Today, we are going to look at a topic that seems, very small.
It does.
But if you get it wrong, the entire structure of your chemistry answers can just collapse.
Absolutely. We're looking at Unit 9, amines, and specifically the focus is on nomenclature.
Right, nomenclature.
And it's often ignored by students. They think, oh, I'll just memorize the reactions.
I can see that happening.
But nomenclature is the language. I mean, if you cannot speak the language, how can you write the answers correctly?
Exactly. And I want to start with a question for you and for everyone listening.
Okay.
When you hear the word methylamine, what comes to your mind?
Methylamine.
Yes. My first instinct is, okay, methylamine must refer to any amine that has a methyl group attached to it.
Right.
Does that make sense? I mean, if I have a big molecule with a nitrogen and I just stick a methyl group on that nitrogen, surely I can call it a methylamine.
See, that is the most common mistake.
Yeah.
And it's a very dangerous assumption to make. Yes. If you think methylamine is some kind of general category, you will definitely lose marks. Methylamine is a specific name.
For just one molecule.
For one specific molecule. Kenya, I use in Euro. That's it.
Ah.
So if you have a molecule like, say, CaU-NHCS, which is a benzene ring with a nitrogen and then a methyl group, you cannot call that methylamine.
Even though it has a methyl and an alamine.
Even then, because the structure is completely different. That molecule is N-methylaniline.
N-methylaniline.
They might sound a bit similar to an untrained ear, but in the, let's say, the warehouse of chemistry, they're in totally different aisles.
That's a great way to put it. And that's exactly why we are here. We need to master these IUPAC rules for amines.
So that when we read a name, we know exactly what the structure is, without any doubt.
Correct. We're not just learning this to pass the Class 12 board exam.
Although that is very important, of course.
Of course. But we are learning this because nomenclature is all about precise communication.
It is about why we care. I mean, if you confuse methylamine and dimethylamine, you are dealing with two substances that have very different boiling points. Different reactivity.
So in a laboratory, if you use the wrong chemical because you misunderstood the label,
it can be dangerous. Precision is essential. It's needed to read chemical literature to perform synthesis without making very serious errors. So our mission today is to master these rules.
Okay, let's do it. Let us start at the simplest level. When we talk about nomenclature for amines, what's the basic logic?
At the simplest level, nomenclature is just the systematic naming of amines based on their structure. We can divide them into two main categories to make it easier.
Which are?
Aliphatic amines and aromatic amines.
Okay, let's take aliphatic amines first.
Yeah.
These are the straight carbon chains, right?
Yes, the chains. For these, you can follow a simple three-step process. First, you identify the longest carbon chain that contains the nitrogen atom.
Okay, the longest chain containing the nitrogen. That's the parent chain.
Correct. Second, you must number that chain. And this part is vital. You must number it in a way that gives the nitrogen atom the lowest possible position number.
The lowest possible number, so we have to prioritize the nitrogen.
Always. And third, you name it as a derivative of the alkane. You take the name of the alkane, let's say propane, and you replace the final letter E with the word amine.
So propane becomes propanamine.
Precisely.
That sounds simple enough. Replace E with amine. What about the aromatic ones then, the ones with the benzene ring?
For aromatic amines, the rules are actually quite friendly. The simplest one is CAH, NHers.
Right.
Its common name is aniline. And the good news is the IUPAC system has accepted aniline as the official parent name.
Oh, that's convenient. So we don't need to call it benzenamine or something complicated like that.
You can call it benzamine, and it's not wrong, but aniline is widely accepted and, frankly, preferred. Everything else is then named as a derivative of aniline.
I want to help our listeners visualize this because just listing rules can be dry, but pictures, they stick in the mind.
Good idea.
I want you to imagine you are working in a massive warehouse.
Okay, a warehouse.
And your job is to label all the boxes so that anyone can find exactly what they need.
I'm with you.
Each amine molecule is a box. The IUPAC system is your protocol, your rule book, for writing the label on that box.
Okay, so the system is the rule book.
Yes. First, you measure the box size, that's finding the longest carbon chain. Then you mark exactly where the nitrogen is located on that box. You use a number for that.
The position number.
Exactly. And finally, you stamp the label with aminimine. If you forget the number, no one knows where the handle is.
That is a good image. And to add to that visualization,
Yeah.
What's really happening when we have extra groups on the amine?
Go on.
Sometimes you have alkyl groups attached directly to the nitrogen handle itself.
So not on the box, but right on the handle.
Exactly. In our warehouse, these are like little colored tags you attach to the nitrogen handle.
Okay, tags.
And we name these using the prefix N.
A capital N with a dash.
Yes. That capital N tells the reader, hey, listen, this group is not on the carbon chain. It is sitting right on the nitrogen atom.
Like an N-methylaniline, which you mentioned earlier.
Correct. Tells you the parent is aniline, and there is a methyl tag hanging directly on the nitrogen.
Okay. So if we were to write down an anchor definition for our notes, something really solid and safe for the exams, what would that be?
I would write this down. Nomenclature of amines follows IUPAC rules. The nitrogen-containing chain is named with the suffix ribamine, and the position of nitrogen is indicated by a number. Alkyl groups attached directly to nitrogen are prefixed with N.
That is perfect, clear and concise. Now, I know students often get confused about the numbering. Is there a specific trap here they fall into?
Yes, there is. The misunderstanding trigger is the priority order for numbering.
Ah.
Students often confuse the position of nitrogen with the position of other substituents, like methyl branches on the main carbon chain. They might start numbering from the wrong end to give the branch a low number.
And how do we fix that? What's the rule?
The fix is to remember this. For amines, the nitrogen atom gets the lowest possible position number. It takes priority over simple alkyl groups.
So it's the most important thing on the chain?
Yes. Just like the OH group gets priority in alcohols. Same logic.
So if I have a choice between giving nitrogen position number 1 or, say, number 3, I must choose 1.
Absolutely. You must choose one, no question.
Let's unpack this a bit more with some analogies, because sometimes these abstract chemical names are hard to remember. You mentioned comparing it to naming a person.
Yes, this is what I call the last name, first name analogy.
Okay.
Think of the chemical name like a human name. The last name is the parent chain like propanamine or aniline. This tells you which family the molecule belongs to.
I see. The family name and the first name.
The first name, which are the prefixes, identifies the specific individual in that family. For instance, N-methylaniline.
So aniline is the family name. That's the benzene ring with the nitrogen.
Correct. And N-methyl is the first name. It tells you, I am the methyl version from the aniline family. It clarifies the parent and the specific modification.
That makes so much sense. You also had another analogy about a postal address. I think that one is very good for the aliphatic amines.
Yes, the postal address analogy is very precise. Think of the longest carbon chain as the street name.
Okay, the street. Let's say Propane Street.
Good. Now, the house number is the position of the nitrogen. It tells you exactly where on the street the nitrogen lives. Is it at house number 1 or house number 2?
And if there are groups attached to the nitrogen itself...
Those are the residents living inside that house. The N groups tell you who is inside that specific house. So enol means inside the house of nitrogen, there is an ethyl resident.
That clarifies it perfectly. You need the street, which is the chain, the house number, which is the position, and the residents, which are the N groups, to deliver the letter correctly.
Exactly. No ambiguity.
But tell me, why do we even have this complex system? Why not just use the old names? I have heard of names like picoline or toluidine.
Well, historically, we did use all sorts of haphazard names. We had things called pungent base or volatile alkali.
Pungent base.
Yes. Now, imagine trying to order pungent base from a chemical supplier today. What would you even get?
Probably something that smells terrible, but you would have no idea what the formula is.
Exactly. The IUPAC system solves this huge problem of ambiguity. We needed to distinguish between isomers. Think about methylamine and dimethylamine. They sound similar, but they are very different molecules.
So the system ensures that a scientist in India and a scientist in Germany are talking about the exact same molecule.
Precisely. It's a universal language.
I want to take our listeners through a mental movie now.
Okay.
I want you to close your eyes for a moment, unless you are driving or walking on the road, of course.
Yes, safety first.
Okay, so visualize a street. This street is the carbon chain. See the numbers painted on the pavement in front of each house? 1, 2, 3.
Okay, I can see the street.
Now, see a specific house where the nitrogen lives. The address of this house is its position number. If the nitrogen is at the very end of a 3-house street, the address is 1.
Right. Propan-1-amine.
Now look inside that house. Visualize the residents living with the nitrogen. If there are alkyl groups, like a methyl group living right there with the nitrogen, I want you to visualize them wearing a cap. A cap with a big letter N printed on it.
A cap with an N. That's good. I like that.
That N label tells you they're with the nitrogen, not just somewhere on the street.
And what if we want to visualize an aromatic amine?
Good question.
For an aromatic amine, I'd say visualize a big hexagonal fortress as your benzene ring.
The fortress, okay.
Attached to it is the nitrogen. This entire fortress plus nitrogen unit is called aniline. Any extra flags or banners you see flying on the nitrogen are the N substituents.
That mental image really helps. It separates the main parent structure from all the attachments. Let's look at some examples from real life in the lab now to see why all this precision matters so much.
Okay, let's start with an observable phenomenon in the lab. A very common mistake students make is confusing aminobenzene with benzylamine.
They do sound very similar, aminobenzene and benzylamine.
They do. But aminobenzene is just another name for aniline. The nitrogen atom is touching the benzene ring directly.
Okay, direct contact.
But benzylamine is CH NH. Here, the nitrogen is attached to a CH group, which is then attached to the ring.
Ah, so there is a spacer carbon in between.
Exactly. So one has the nitrogen directly on the ring, and the other has that carbon spacer.
And that makes a difference.
A huge difference. Chemically, they're completely different. Benzylamine is actually aliphatic in nature, while aniline is aromatic. If you use the wrong name in a reaction, you will get a completely different product, or maybe no reaction at all.
That's a very serious error. Okay, what about in technology or medicine?
Pharmaceutical chemistry relies entirely on this. Let's take the example of epinephrine.
Which is also known as adrenaline.
Correct, the life-saving drug. Its IUPAC name is, well, it's quite complex. 4,1,R,1. Methylaminoethyl benzene 1,2-diol.
Wow, that is a very long name.
It is. But look at the precision in it. It says benzene 1,2-diol, so we know the ring has two OH groups and where they are. It says ethyl, so we know the chain length. And it says methlamino, so we know exactly what is attached to the nitrogen.
So if you know the rules, you could draw the complete structure of adrenaline even if you've never seen it before, just from the name.
Exactly. And in medicine, that kind of precision is a safety issue. A slight change in the position of that methyl group could turn the medicine into a poison.
I want to revisit that counterintuitive example about methium. We touched on it at the start, but I want to make sure everyone understands the why.
Yes, that's a good one to clarify. The naive assumption is thinking methylamine is a general term that covers CO, Euro, and H, arrow.
You see a methyl, you see an avon, you think methylamine.
Exactly. But actually,
COHNH is N-methylaniline.
yes. And the reason the why is because of the priority rules.
The parent chain.
Yes. The benzene ring is larger and more complex than the little methyl group. So the benzene part becomes the parent, which is aniline. The methyl group is just, I guess, a substituent on the nitrogen.
Whereas in true methylamine,
In true methylamine, which is chinacea, the methyl group is the only carbon chain there is, so it gets to be the parent. The context completely changes the name.
that is a very, very important distinction. You have to look at the whole molecule to decide who is the parent.
Always identify the parent first.
Okay, we have covered the concepts, the analogies, and the examples. Now, for the students listening who want to score full marks, let's go through the exam-safe clarity lines. These are the key takeaways.
Let's do it.
Clarity line number 1. For aliphatic mens, identify the longest carbon chain containing nitrogen, number it to give nitrogen the lowest position number, and apply the suffix ephenemine.
And this is important because you're replacing the E of the alkane. So do not write propanamine. You must write propanamine. Drop that final E.
Good point.
Okay.
Clarity line 2. For aromatic amines derived from benzene, the parent name is aniline.
And just remember, if you are numbering the substituents on the ring, the carbon that is attached to the nitrogen is always position number 1.
Always 1. Got it. Clarity line 3. Alkyl groups bonded to nitrogen are indicated by the prefix N, followed by the alkyl name.
This is critical. If you don't write that N, the examiner will assume the group is on the carbon chain somewhere. You must use the N to be clear.
Right. Clarity line 4. The position of nitrogen is chosen to be the lowest possible number.
Priority, priority. It's always propan-1-amine, not propan-3-amine. The lowest number wins.
And finally, clarity line number 5. For amines with complex constituents, use alphabetical order for prefixes.
Yes, just like in the rest of organic chemistry. E for ethyl comes before M for methyl. So you would write N-ethyl N-methylaniline. Don't forget to check your alphabetical order.
Those are the 5 golden rules. If you follow them, you really can't go wrong.
Indeed, it is a very systematic process once you get the hang of it.
So, let us try to summarize everything we have discussed today in a short recap for everyone to remember.
Sure. First, remember the core idea. It's all about finding the longest chain, giving nitrogen the lowest number, and using the suffix -amine.
Longest chain, lowest number, amine.
Second, keep that postal address analogy in your mind. The chain is the street, the number is the house, and the N groups are the residents living inside that house.
And please don't forget the example of benzylamine versus aniline. That one little carbon spacer makes a huge chemical difference. Precision prevents lab accidents.
And finally, the clarity on the N prefix. If a group is sitting directly on the nitrogen, you have to label it with N. It is the only way to communicate the structure correctly and get full marks.
Mastering nomenclature is really like learning the grammar of chemistry, isn't it?
It is.
Once you know the names, you can stop struggling with what is this molecule and start predicting how will this react.
That's absolutely right. It unlocks the entire unit. Once you can speak the language, the actual chemistry becomes much, much easier.
Thank you for breaking this down so clearly. Listeners, keep practicing those names, draw out the structures, and remember,
Nitrogen gets the lowest number.
always happy studying.
See you in the next deep dive.